Methods of recovery. Several methods of recovery for refrigerants are used in the systems mentioned in this text. All of these refrigerants are thought of as high-pressure refrigerants. They are also called low boiling point refrigerants. Some of the CFC refrigerants, such as R11, are low-pressure refrigerants, high boiling point. It boils at 74.9 degrees Fahrenheit at atmospheric pressure. This refrigerant is very hard to remove from a system because of its high boiling point. A very low vacuum must be pulled to boil it all from the system. This is different from R12, which has the highest boiling point of the commonly used refrigerants in small systems. It boils at minus 21.62 degrees Fahrenheit at atmospheric pressure. That means that if the temperature of the system is above minus 21.62 degrees Fahrenheit, the R12 will boil and can be removed from the system easily. Refrigerant 134A has a boiling point of minus 15.7 degrees Fahrenheit. The boiling point of some refrigerants at atmospheric pressure are as follows. With the boiling point in degrees Fahrenheit: R11 plus 74.9, R12 minus 21.62, R22 minus 41.36, R123 plus 82.2 to replace R11, R125 minus 55.3, R134A minus 15.7 to replace R12, R500 minus 28.3, R502 minus 49.8, R410A minus 61 to replace R22, R404A minus 51 to replace R502, R402A minus 54, R402B minus 51. The following chart shows that most of the common refrigerants discussed in this text have high vapor pressures and will be relatively easy to remove from the systems. The vapor pressures at a room temperature of 70 degrees Fahrenheit would be as follows. Listing the refrigerants and their vapor pressure at 70 degrees Fahrenheit: R12, 70 psig, R22, 121 psig, R125, 158 psig, R134A, 71 psig, R500, 85 psig, R502, 137 psig, R410A, 201 psig, R404A, 148 psig, R402A, 158 psig, R402B, 147 psig. The boiling point is important because the EPA has ruled on how low the pressure in a system must be reduced to accomplish the recovery guideline. Passive recovery. Passive recovery, or system-dependent recovery, is when the service technician uses the internal pressure of the system or the system's compressor to aid in the refrigerant recovery process. If the system has an inoperative compressor and passive recovery is to be used, the refrigerant must be recovered from both the low side and the high side of the system and achieve the recovery efficiency requirements. Many times, a seasoned service technician will gently tap the side of the compressor's shell with a soft wood, rubber, or leather mallet. This action will agitate the crankcase oil and cause any refrigerant dissolved in it to vaporize and be recovered more easily. Because the compressor is not working, the service technician can also use the aid of a vacuum pump, as long as its discharge is not into a pressurized container, but to the atmosphere only. If the compressor is working, the technician can recover refrigerant only from the high side of the system. All manufacturers of appliances containing Class 1 CFC or Class 2 HCFC refrigerants must supply a service aperture or process stub on the system. Also, non-pressurized containers must be used to capture the refrigerant when a passive recovery process is used. Figure 9-35. Passive refrigerant recovery is used often on small appliances that contain 5 pounds or less of refrigerant in their systems. Active recovery. Active refrigerant recovery is the method used by technicians the greater part of the time. Refrigerant is removed through the use of a certified self-contained recovery machine. The refrigerant or air conditioning system's compressor is not used with an active recovery method. These machines are usually capable of both the recovery and recycling of refrigerant. To speed the recovery of refrigerant in an active recovery process, always recover at the highest possible ambient temperature to cause a higher pressure in the system being recovered. Safety precaution. A high-pressure reading in a recovery tank is an indication of air or other non-condensables in the tank. Dangerous pressures could result. After the tank has cooled to the ambient temperature, a temperature-pressure relationship with the ambient temperature will indicate what the recovery tank pressure should be. Before starting a recovery, it is always important to know what type of refrigerant is in the system to be recovered. Unintentional mixing of refrigerants can also cause high pressures in a recovery tank. Always make sure that refrigerants are not mixed together in a recovery tank. The following are some suggestions for how to avoid mixing refrigerants in a recovery tank. Use pressure-temperature charts for refrigerant in the recovery cylinder. Make sure the recovery machine has a self-clearing feature. Dedicate a lubricant-specific recovery unit to specific refrigerants. Dedicate a certain refrigerant cylinder to a specific refrigerant and mark the cylinder appropriately. Use commercially available refrigerant identifiers and air detection devices on the recovery tank. Keep appropriate records of refrigerant in inventory. Effective August 12, 1993, all companies have had to certify to the EPA that they have recovery equipment to perform adequate recovery of the refrigerant for the systems they service. Equipment manufactured before November 15, 1993 must meet qualifications set for this time period. Figure 9-20. Equipment that is manufactured after November 15, 1993 must be approved by an ARI-approved third-party laboratory to meet ARI Standard 740. As of November 15, 1993, the following is the guide used by the EPA for evacuation of equipment except small appliances and motor vehicle air conditioning. 1. HCFC 22 appliance or isolated component of such appliance, normally containing less than 200 pounds of refrigerant, 0 psig. 2. HCFC 22 appliance or isolated component of such appliance normally containing more than 200 pounds of refrigerant, 10 inches Hg vacuum. 3. Other high-pressure appliance or isolated component for such appliance normally containing less than 200 pounds of refrigerant, R12, R500, R502, R114, 10 inches Hg vacuum. 4. Other high-pressure appliance or isolated component of such appliance normally containing 200 pounds or more of refrigerant, R12, R500, R502, R114, 15 inches Hg vacuum. 5. Very high-pressure appliance, R13, R503, 0 psig. 6. Low-pressure appliance, R11, R113, R123, 25 mm Hg absolute, which is 29 inches Hg vacuum. Figure 9-20. The exception to the preceding would be when the system could not be reduced to these pressure levels. For example, when the system has a large leak, there is no need to pull the system full of air. Technicians are required to be certified to purchase refrigerant after November 14, 1994. The EPA defines a technician as any person who performs maintenance, service, or repair that could reasonably be expected to release Class 1 CFC or Class 2 HCFC substances into the atmosphere, including but not limited to installers, contractor employees, in-house service personnel, and in some cases, owners. There are 4 different certification areas for the different types of service work. A person must take an EPA-approved proctored test and pass both the core section and either the Type 1, Type 2, or Type 3 certification sections to become certified. A person who passes the core and certification types 1, 2, and 3 is automatically universally certified. Consult with your company's training official, industry chapters, or local wholesale supply houses for training information, testing dates, and test sites. Once a technician is certified, it will be the certified technician's responsibility to comply with any changes in the law. Type 1 certification. Small appliance, manufactured, charged, and hermetically sealed with 5 pounds or less of refrigerant. Includes refrigerators, freezers, room air conditioners, package terminal heat pumps, dehumidifiers, under-the-counter ice makers, vending machines, and drinking water coolers. Type 2 certification. High-pressure appliance. Uses refrigerant with a boiling point between minus 50 degrees Celsius, minus 58 degrees Fahrenheit, and 10 degrees Celsius, 50 degrees Fahrenheit, at atmospheric pressure. Includes 12, 22, 114, 500, and 502 refrigerant. Replacement refrigerants for these refrigerants are also included. Type 3 certification. Low-pressure appliance. Uses refrigerant with a boiling point above 10 degrees Celsius, 50 degrees Fahrenheit, at atmospheric pressure. Includes 11, 113, 123, and their replacement refrigerants. Universal certification, certified in Type 1, 2, and 3. It is believed that technician certification should ensure that the technician knows how to handle the refrigerant in a safe manner without exhausting it to the atmosphere. The refrigerant may be removed from the system as either a vapor or a liquid in the partial liquid and vapor state. It must be remembered that lubricating oil is also circulating in the system with the refrigerant. If the refrigerant is removed in the vapor state, the oil is more likely to stay in the system. This is desirable from two standpoints. 1. If the oil is contaminated, it may have to be handled as a hazardous waste. Much more consideration is necessary, and a certified hazardous waste technician must be available. 2. If the oil remains in the system, it will not have to be measured and replaced back to the system. Time may be saved in either case, and time is money. The technician should pay close attention to the management of the oil from any system. This cylinder must be clean and in a deep vacuum before the recovery or recycle process is started. It is suggested that the cylinder be evacuated to 1000 microns, 1 millimeter Hg, before recovery is started. Refrigerant from a previous job will be removed with this vacuum. All lines to the cylinder must be purged of air before connections are made. Safety precaution. Refrigerant must be transferred only to approved refrigerant cylinders. These cylinders are approved by the Department of Transportation, DOT. Never use the DOT-39 disposable cylinders. The approved cylinders are recognizable by their color and valve arrangement. They are yellow on top with gray bodies and a special valve that allows liquid or vapor to be added to or removed from the cylinder. Figure 9-21.